Hey, Mr. Harridan here. We're going to go over intermolecular forces, the IMFs here. One of my favorite discussions of them all. First of all, we went over intramolecular bonding. Occurs between two atoms. It's when we have a compound that is ionic or covalent, but we're referring to intramolecular bonding when we're talking about ionic or covalent. Okay? Yeah. Those were the network solid, metallic bonding, ionic bonding, and covalent bonding. However, for this discussion, we are doing intermolecular forces. These are the forces that are between the molecules. Okay? These affect the melting points and boiling points, affects the states of the matter, and the stronger the intermolecular force, the higher the melting point or boiling point will be. Okay, so then we have four of them. Okay, there is ion. Okay, this is the dominant force when we have ionic. Isn't it ionic? Don't you think? It's like rain on your wedding day. But ionic, it's when you have a metal and a non-metal, remember? These are the strongest interactions. Ion are the strongest that you can possibly have. Okay? Then we get to hydrogen bonding, right? Now, these are felt in, my favorite word, polar covalent molecules. Okay? This is when you have HF, HO, or HN bonded together. Okay? Those are the only three times it happens. Happens in DNA, for instance. That's how you get your A's to T's and G's to C's based off of hydrogen bonding, which are in polar covalent molecules. Then we have dipole. This is the dominant force felt in polar covalent molecules. Okay? These are all the other polars that are not hydrogen bonding. Okay? They're a little bit weaker because they have a partial positive and they have a partial negative. Okay? And then we get to the last one here, which is nonpolar, which is London dispersion. This is for nonpolar covalent molecules. Yes, I understand when you use the word covalent molecules, it's kind of redundant to say covalent molecules. I got that. Okay, but that's what we're saying. This is the weakest force. Okay, and these are the ones with the lowest boiling points here. So you're looking for ionic here. You're looking for polar. Here, it's HF, HN, or HO. I like to say it's high fun. So, me. These are the other polars, or dipole. And London dispersion is all nonpolars. Okay? Now, this is figuring out the strongest intermolecular force here also. So, if I'm talking about hydrogen bonding, okay, there's also London dispersion there. It's just that hydrogen bonding dominates over London dispersion. So, just so you know. Okay. And remember that these are the four that we need to know is ion, hydrogen bonding, dipole, London dispersion. Okay? And then also to do London dispersion, you have to look at molar masses as well. Okay? If it has a lower molar mass, that means it is weaker. Okay? The higher molar mass will have the stronger IMFs if you're comparing the same things. Okay, let's go to the next page. Next page. This example here. Okay. For each of the following, Determine the intermolecular force type between the molecules and covalent compounds in its state. Put them in increasing order of boiling points here. So we're going to start off with H2S, okay? And the best way to do these is you have to draw the Lewis dot structure. So this has 8 valence electrons, okay? We have an S, we have a bond like this, and it looks like that, okay? You know that this one is polar, just so you know, because there is dots on the central atom. This is asymmetrical, making it an uneven distribution of electrons. Okay, the next one we're going to do here, CH4, also has 8 valence electrons. Okay, so we have a carbon, we have a hydrogen, we have a hydrogen, we have a hydrogen, we have a hydrogen. That's 2, that's 4, that's 6, and that's 8. That's the always methane I've drawn, but that's okay. This one is non-polar. Okay. Then we get to the tricky one here. Lithium is a metal. So when we draw this one here, this one is ionic. We know that because it has a metal. So when we draw lithium bromide, remember lithium has a positive and bromide has a negative, and there are 8 valence electrons around the bromide like this. Okay, because this one also has 8 valence electrons. Remember, when you draw ionics, you have to use brackets. Okay, NH3 is the next one here, so let's do this color. This one also has 8 valence electrons. We have an N, we have an H, an H, an H. You have to do 2, 4, 6, and a pair of dots right here. This one is trigonal pyramid. So guess what this one is? Oh, you know what? You see the stamper. Polar! Because that is unequal sharing. Because a trigonal pyramid is an uneven shape. And then finally, we're going to do CBr4. Okay, bromine has 7 times 4, 28 plus 4 is 32. So we're doing 32 valence electrons on this one here. Okay, so this is the C with the BR, the BR, the BR, the BR, line, 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 and then you put the dots around here until you get to 32, and then make sure everything has 8, and the carbon in the center has to have 8 as well. This one, there is no dots on the center, and it is symmetrical, so this is non-polar. Okay. Okay. Now, figuring out the dominant IMF. Okay. Ionic's easy. It's ion, ion. Okay. Nonpolar is easy as well. It's London dispersion. Because all nonpolars are London dispersion. London dispersion is the weakest. I remember that by singing the song London Bridge is falling down, falling down, falling down. London Bridge is falling down. Because weak! Weak bridges fall down. So this is London dispersion as well. Okay. Now remember, when it's polar, we have choices here. Okay? If we are doing hydrogen bonding here, it has to be polar, and it has to be H with N, O, or F directly bonded to it. So this one right here is hydrogen bonding. Even though this has a hydrogen, there is no nitrogen, oxygen, and fluorine bonded to that one. So that one up there is Dipole, dipole. Just because you have hydrogen doesn't mean it's hydrogen bonding. You have to have it bonded to an N, O, or F. This one also has a hydrogen, but it's not even polar. It's non-polar. Okay? Now we have to rank these. So we know ion is the strongest, so that's going to be number 1. That is going to be the strongest, because we also know that this is actually a solid. Okay? The next one here we're going to do is hydrogen bonding. That's number 2, because this is actually a liquid. Number 3, this is also a liquid. That would be our dipole, dipole. Then we have to do the molar mass thing to determine 4 and 5. This one has the higher molar mass, which means it is stronger than that one, because this is bigger. So this is going to be 4. I still think this is a liquid in real life. It might be a gas, liquid / gas. I don't know off the top of my head. And number 5, CH4 is definitely a gas. If it has the smaller molar mass, it is weaker than the one with the bigger molar mass. Okay, guys are champions. The legend is